At this point, we have 4 tests written against the To-Do app. We've only been running them via the UI, which is great for development and debugging. But in our pipelines, the tests will be executed using the pytest runner, aka the command line with shell scripts and such. However, we have only executed them one by one when we should be running them in parallel. Running tests in parallel greatly reduces execution times, which is crucial for CI/CD. We want fast feedback loops so we can learn and iterate quickly, and a test suite that takes more than 15 minutes starts to feel like an eternity when you're trying to get your pull requests merged so you can work on the next thing. It's up to you as the automation engineer to make sure your tests are designed in such a way that you can execute them in parallel and have short execution times. This is easier said than done, but let's take a look at what we've created so far. Running our tests one by one would take about 10 to 15 seconds, which isn't too bad. However, you're most likely going to be dealing with hundreds or thousands of tests, which would take hours if executed sequentially. Running them sequentially means that you are using one thread for all the tests, which is why only one test is executed at a time, as seen here. When it comes to pytest, we have a few plugins we can use to achieve parallel execution. Pylenium already includes the pytest xdist plugin, which runs tests in parallel by distributing each test to its own thread. In other words, each test would run at the same time using its own thread, and the execution time would be closer to 5 seconds. This may not seem like a lot, but when you have hundreds of tests, the time saved adds up quickly. Like I said before, it's up to you to design your tests so they can be executed in parallel. So there are a couple pitfalls you need to avoid to do this. For example, tests should not share data or state. Sharing data and state between tests can have them tripping over each other because they can affect each other's outcome, which is probably not what you want. We call this data management, and it's one of the most difficult pieces of automated solutions. Tests should not be dependent on each other. If test B only works after test A is executed, then you have to run them sequentially, which breaks the whole parallel strategy. Instead, here are some pieces of advice that can help you make sure you have parallel design. Each test has its own instance of a driver. This also extends to most objects, by the way. Tests should be independent of each other. We talked about this already, but it's one of the most important pieces of parallel design. Tests should manage their own data and state. Each test should have its own setup hooks and then cleanup hooks once it's complete. Tests should be modular, meaning that they should be small and try to test a single thing. Remember, this is good general advice, but do it make sense for you and your context. There's lots to think about, which may seem a little daunting, but luckily Pylenium is parallel first. This means that it's designed to run tests in parallel. For example, just using the py fixture already gives a unique driver to each test. Also, parallel plugins are already included when you install Pylenium, since it comes with pytest and the pytest xdist plugin already. The base command just starts with pytest. Then you include any options followed by the file or directory of tests you want to run. If you ran pytest by itself with no options or arguments, it would just run all the tests that exist in the current project. To run all the tests in our test-todo.py file, the command would look like this. To run those same tests in parallel, you include -n, which means number of threads, followed by the number of tests to execute at the same time. In this example, run 2 tests at a time. Let's switch to VS Code now so we can see this in action. So here we are inside of our test-todo.py file. I'm going to open a terminal. And remember, the command we need to run is pytest plus some options in the directory, right? But because I'm using poetry, I'm going to say poetry run pytest, and then specify the folder I want to execute, in this case, our test_todo.py file. If I execute this command by pressing enter, it's going to run all the tests sequentially, one at a time. So let's see how long it takes. Excellent, they all passed, and it took about 12 seconds. Let's try the same command, but this time let's run it in parallel. Now, your machine can probably handle 2, 3, or 4 threads at the same time, so let's do 2 for now and see what happens. Sweet, running 2 at a time took about 7 seconds. Let's try 4 now and see if we can get down to even less than that. Here we go. Woo, we got down to 5 seconds. Hey, that's pretty good. But notice how we went like in half, right? Running all of them sequentially took about 12 seconds. Running all 4 of them at the same time took 5 seconds. So immediately you can see the benefit of running them in parallel. And like I said before, we didn't have to make any changes to our tests. We just added the -n with the number of threads we wanted to execute. That's the power of Pylenium for you, but also pytest and the pytest xdist plugin. For reference, I've also included an example of a shared global driver in the test shared driver.py file. You don't need to copy the code into your project. It's just meant as an example of what not to do, so you can play around with it if you like. I included some of the tidbits here with some emojis, as you can see, but also you can see that we have what looks very similar to what we had before with our to-do page, but the big difference is that we're using the shared global driver and the single page object that's shared now between all of our tests. Feel free to try this code out, of course, but some of the things you're going to realize, for example, is that the driver is not inside of a fixture. So when the test is complete, the browser isn't going to close. You'll also see some other side effects, I'm sure, but just take a look at it, play around with it if you like, and make sure to avoid sharing drivers, sharing page objects, and sharing data between your tests. Although running tests in parallel is considered mandatory in a lot of frameworks, you'll quickly realize that your machine is limited and can only handle so many tests at a time. Eventually, you will need to scale your compute power so you can run more tests in parallel, especially as your automated suite grows. There are many solutions out there, but LambdaTest happens to include scaling in their cloud solution as well, which brings us to the final module, cross-browser testing with LambdaTest. See you in the next video.